This is SpaceTime Series 27, Episode 75, for broadcast on the 21st of June 2024. Coming up on SpaceTime, how the red planet Mars lit up during last month's solar storm, unexpected differences discovered in the disk of the Milky Way galaxy, and scientists develop a new atlas dealing with space health. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Last month's spectacular solar storms, which hit the Earth, triggering stunning auroral light displays, also impacted the red planet Mars, providing astronomers with a treasure trove of new data. Scientists have been waiting for years to see how the sun would impact Mars as our local star moves towards the climax of its 11-year solar cycle, and they weren't disappointed. Over the past month, NASA's Mars rovers and orbiters have provided researchers with front-row seats to a series of solar flares and coronal mass ejections that have bathed the red planet, in some cases even causing Martian auroras. This science bonanza has offered an unprecedented opportunity to study how such events unfold in deep space, as well as how much radiation exposure the first humans on Mars are likely to encounter. The biggest event occurred on May 20th, with a solar flare later estimated to be an X-12, based on data from the joint NASA-ESA Solar Orbiter spacecraft. The flare sent out X-rays and gamma rays towards the red planet, while a subsequent coronal mass ejection launched billions of tons of charged particles. Moving at the speed of light, the X-rays and gamma rays from the flare arrived first, while the charged particles trailed slightly behind, but still reaching Mars in just tens of minutes. The unfolding space weather event was closely tracked by scientists at NASA's Moon to Mars Space Weather Analysis Office at the Goddard Space Flight Center in Greenbelt, Maryland. They say if people had been standing next to the Mars Curiosity rover at the time, they would have received a radiation dose of 8,100 micrograys. That's the equivalent of 30 chest X-rays at once. While not deadly, it was nevertheless the biggest surge measured by Curiosity's radiation assessment detector since the rover landed in Gale Crater 12 years ago. The data will help scientists plan for the highest levels of radiation exposure that might be encountered by people. It's thought sheltering on the cliffsides or in lava tubes might provide additional shielding for astronauts from such an event. Principal investigator Don Hassler from the Southwest Research Institute in Boulder, Colorado, says that in Mars orbit, or in deep space for that matter, the radiation dose would have been significantly higher. During the May 20 event, so much energy from the storm struck the surface that the black and white images taken by Curiosity's navigation cameras danced with snow, white streaks and specks caused by charged particles hitting the cameras. Similarly, the STAR camera on NASA's 2001 Mars Odyssey orbiter, which is used for orientation, was inundated with energy from the solar particles, momentarily blacking out. Even with a brief lapse in STAR camera operations, the orbiter was still able to capture vital data on X-rays, gamma rays, and charged particles using its high-energy neutron detector. Also, this wasn't Odyssey's first brush with a solar flare. Back in 2003, solar particles from a solar flare that was ultimately estimated to be an X-45 totally fried Odyssey's radiation detector, which was designed to measure such events. High above Curiosity, NASA's Mars Atmosphere and Volatile Evolution, or MAVEN orbiter, captured another effect of the recent solar activity, glowing auroras over the red planet. Now, the way these auroras occur on Mars is very different from those seen on Earth. See, the Earth is mostly shielded from charged particles by its magnetic field, and the magnetic field is generated by the planet's rotating molten metal outer core acting like a geodynamo. This normally limits space weather events like auroral activity to regions near the poles. Mars, however, being only a third the size of the Earth, has cooled down much more quickly. It therefore lost its internally generated magnetic field eons ago as its core began to solidify. This means that the red planet has no global protection from the barrage of energetic particles. When charged particles hit the Martian atmosphere, it results in auroral activity that engulfs the entire planet. During solar events, the Sun releases a wide range of energetic particles, but only the most energetic can reach the surface of Mars to be measured by Curiosity. Slightly less energetic particles, those that cause the auroral displays, were sensed by MAVEN's Solar Energetic Particle Instrument. And scientists can use that instrument's data to build a timeline of each minute as the solar particles scream past, meticulously teasing apart how the event evolved. This was the largest solar energetic particle event that MAVEN had ever seen. And it doesn't end there. There have been multiple solar events over past weeks, so scientists are seeing wave after wave of particles hitting Mars. The data coming from NASA's spacecraft won't only help future planetary missions to the Red Planet, it's contributing to a wealth of information being gathered by the agency's other heliophysics missions. They include Voyager, the Parker Solar Probe, and the forthcoming ESCAPADE mission. ESCAPADE's targeted for launch later this year. It'll consist of 2 satellites which will orbit Mars and observe space weather from a unique dual perspective that's more detailed than what can be achieved by MAVEN. This report from NASA TV.
This is a big year for NASA's MAVEN orbiter. What it could learn could someday help future astronauts safely land on Mars and provide us with a new view of the sun. This is mission control at NASA's Jet Propulsion Laboratory. This is where all of the data from MAVEN comes through. 10 years ago, we sent MAVEN to Mars to measure space weather and how it interacts with the upper atmosphere. This includes solar flares, which are giant explosions on the sun, which send radiation into space. Every 11 years, the sun goes through cycles of activity. This year, we've seen more space weather than we ever have during the entire mission. And while solar flares can occur at any time, they occur more frequently and more intensely at the peak of the cycle, called solar maximum. Right now, we're almost at that peak, and I'm really excited about what solar flares can teach us about the red planet. MAVEN is one of 2 missions studying radiation at Mars. The orbiter is able to observe many phenomena from the sun, including radiation, high-energy particles, and magnetic fields. MAVEN can also see stunning auroras from its vantage point high above the planet, which future astronauts might be able to see someday. Meanwhile, down on the surface of Mars, the Curiosity rover has a radiation detector called RAD. It studies high-energy particles that get all the way through the atmosphere and down to the surface. Together, MAVEN and Curiosity give us a better understanding of the radiation environment at Mars. Studying how intense solar flares can get during solar maximum can help NASA develop protection for future astronauts, robots, and spacecraft. There's another advantage to studying the sun from Mars. Here on Earth, we can only see one side of the sun. But when MAVEN is on the other side, it can spot activity coming days before we can. On a personal note, MAVEN is my spacecraft baby, and I am so excited about observing the next few years of solar flares, space weather, and the atmosphere of Mars.
And in that report from NASA TV, we heard from MAVEN Principal Investigator Shannon Curry from the University of Colorado. This is SpaceTime. Still to come, unexpected differences discovered in the disk of the Milky Way galaxy, and a new medical atlas dealing with space health. All that and more still to come on SpaceTime. Astronomers have discovered an unexpected difference in the thickness of the main disk of the Milky Way galaxy. It seems the inner part of the disk has only half the thickness of the outer part. Our Milky Way galaxy includes a nucleus and thick bar-like central bulge surrounded by a disk of spiral arms. These spiral arms are divided into a densely packed thin disk which contains about 85% of the stars in the galactic plane and 95% of the total disk stars, including our Sun. It's encapsulated inside a sparser, thick disk of young stars, and the combined disk is then enclosed in a spherical component massive halo of ancient stars. Overall, the galaxy has a rough diameter of 87,400 light-years. Its thin disk is about 1,300 light-years thick, with the surrounding thick disk stretching as much as 16,000 light-years above the galactic plane. Recent simulations suggest that there's a dark matter area, also containing some visible stars, which may extend up to a diameter of almost 2 million light-years. That's the same as the distance between the Milky Way and the neighbouring Andromeda galaxy. Space may appear vast and empty, but it's full of cosmological objects that are invisible to the human eye. From our vantage point on Earth, many of these objects can fall between astronomers and what they hope to observe, impacting what they find. And this scenario was recently encountered by scientists with the United States National Science Foundation's Green Bank Observatory. They were attempting to study the Smith Cloud, a vast nebulosity veiled away behind dense layers of gas and dust on the other side of the Milky Way galaxy. The Smith Cloud contains enough gas to fill 1 million suns, and it's expected to crash into the Milky Way in about 27 million years from now. Astronomers have been intrigued by this monstrous high-velocity cloud ever since it was first discovered in the 1960s. So the 100-metre Green Bank Radio Telescope, together with a smaller 20-metre dish and NASA's Hubble Space Telescope, were being used to study this mysterious and massive body of gas. Green Bank Observatory astronomer Tony Mittner planned to observe the spot where part of the Smith Cloud's already interacting with the Milky Way. But at this distance and on the other side of the Milky Way galaxy, the observation is tricky, even for a telescope as sensitive as Green Bank's. Mittner was looking for dust and the faint emissions of hydroxyl molecules. The Smith Cloud's thought to have very little dust and almost no hydroxyl, while most clouds in the Milky Way contain lots of both. If Mittner found an area of accretion in the Milky Way where parts of the Smith Cloud had begun to mix, he would see differences in their composition, learning more about the interaction as a result. But instead, Mittner's observation revealed new information about the structure of the inner part of the Milky Way galaxy itself. While looking through the Milky Way to search for hydroxyl molecules in his target area, Mittner determined the thickness of the layer of molecules in the inner galaxy. Amazingly, this revealed the scale height of molecular gas in the inner Milky Way, measuring in at around 330 light-years across. And that's unexpected, because observations of molecules in the outer part of the Milky Way show about double this thickness. What the new discovery means is that this part of the inner galaxy is very different from the outer part of the galaxy, and astronomers will now need to undertake lots more observations in order to better understand our Milky Way galaxy's structure and evolution. This SpaceTime. Still to come, a new atlas on space health, and later in the science report, could melatonin supplements improve your eyesight in older age? All that and more still to come on SpaceTime. From broad-ranging molecular changes and DNA damage to immune system disruptions, how does spaceflight affect human biology? Well, now, a new series of papers called the Space Omics and Medical Atlas covering this complicated topic is being published in the journal Nature. The research package includes an analysis of samples collected from the first all-civilian crew from SpaceX's Inspiration 4 voyage and from astronauts who spent either 180 days or a full year aboard the International Space Station, in the process providing longer-term views on the effects of spaceflight on human health. As more people venture into space, understanding the health risks associated with space exploration will be key in terms of preparation for long-term lunar and eventually Martian missions. Remember, a mission to Mars will take at least 6 months each way, and if they decide to stay on the red planet for a full orbit around the Sun, that'll stretch out to over 2 Earth years. The authors suggest these new resources will help accelerate precision aerospace medicine, improve health monitoring, and inform risk mitigation for future missions. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study suggests that melatonin supplements, commonly used as sleeping aids, may improve your chances of maintaining your eyesight in older age. A report in the Journal of the American Medical Association looked at health records of over 200,000 people who had either no history of age-related eyesight decline or were in the early stages of such decline. Comparing those who used melatonin supplements with those who didn't, the authors found melatonin was linked to a lower risk of developing age-related eyesight deterioration, especially among people with no decline, and a lower risk of further deterioration among those at an early stage of decline. Now, the authors admit other lifestyle factors could have influenced their results, and so they stress that lots more work needs to be done in order to confirm this link. Paleontologists have described a newly identified 100-million-year-old fossilized pterosaur recently discovered in Western Queensland. The flying reptile from the age of the dinosaurs has been named Halischia peterseni and featured a 4.6-metre wide wingspan. The description, published in the journal Scientific Reports, was based on the shape of its skull, the arrangement of its teeth, and the shape of a single shoulder bone. When the TV soap opera Neighbours briefly ended in 2022, fans of the show complained about experiencing strong grief, loss, and sometimes a lack of closure. The findings, reported in the journal PLOS ONE, are based on a survey of nearly 1,300 devotees conducted by researchers shortly after the screening of what was thought to be the long-running soapie's final episode. That's before it was resurrected by Amazon a few months later. The survey looked at emotions, it measured thoughts related to grief, acceptance that the series had ended, distress at the loss of relationships with favourite characters, feelings of closure, and how grateful the fans were for the series. Superfans, fans who watch Neighbours to be entertained and exposed to different lifestyles, and those who had formed empathic parasocial relationships with characters were the most likely to experience grief when the final curtain fell. The findings shed new light on the parasocial relationships some people can form with fictional characters and provide evidence that humans really can experience the loss of a TV series or character as grief. A new report by the CIA claims Havana syndrome is nothing more than anxiety, mass suggestion, and normal medical conditions that can happen to anyone. The syndrome describes a set of medical symptoms that were experienced by United States and Canadian embassy staff in Cuba, later in China, between 2016 and 2018. Victims typically reported suddenly hearing strange, grating noises that seemed to be coming from just one specific direction, and then experiencing it as a pressure or vibration, eventually triggering headaches, dizziness, hearing loss, memory loss, and nausea. Subsequent medical examinations of victims discovered brain injuries similar to a concussion, and follow-up investigations of recordings undertaken during these events did pick up unusual infrasound waves. Infrasound involves sounds lower than 20 Hz, which are inaudible to humans. The incident sparked speculation that these could have been attacks targeting diplomats using some sort of acoustic weapon. However, others claimed it could have been nothing more than some type of mass hysteria illness, exposure to neurotoxins from earlier fumigation works, feedback from faulty listening devices implanted by enemy operatives, or even the chirp of either Indian short-tailed crickets or Jamaican field crickets. What does make this story interesting is that Russia had previously undertaken acoustic attacks against the US Embassy in Moscow. However, those incidents involved pulse radio frequency microwave radiation, which is ultrasound, not infrasound. That involves frequencies over 20,000 Hz, which are also inaudible to humans. And just a few years ago, the Chinese Academy of Sciences revealed details of a new sonic gun that focused infrasound waves designed to cause extreme discomfort and physical distress to people by generating vibrations in the eardrums, eyeballs, stomach, liver, and brain. Infrasound's effects include vertigo, imbalance, intolerable sensations, incapacitation, disorientation, nausea, vomiting, bowel spasms, and resonances in inner organs, including the heart. Indian soldiers reported just such symptoms in their face-off against Chinese troops during standoffs at the joint India-China border. And it doesn't end there. Recently, Australian Capital Territory Police were also accused of deploying sonic weapons known as long-range acoustic devices against protesters in Canberra. Police claimed they were only being used to broadcast messages or alarms at high volumes, but numerous protesters reported feeling nauseous and sick from the effects of the sonic weapons. It's also claimed that New South Wales Police deployed similar weapons during Black Lives Matter protests in Sydney in 2020. The CIA claims that most of the 1,000 Havana syndrome cases that have been investigated by the US government have environmental explanations or are the result of undiagnosed medical conditions and stress, not the result of an international campaign by Russia or some other foreign power. Tim Mendham from Australian Skeptics says the claims are truly fantastic.
Havana syndrome is something that started in 2016, where staff at the US consulate in Havana, Cuba, started saying they felt ill, they felt sick, headaches, and all sorts of things, and they were claiming hearing loss and various brain issues, quite serious, and people trying to figure out why, and the sort of almost instant reaction was that the Russians were firing beams of some sort at them to actually make the staff sick. This became a bit of a cause célèbre in its own right. People started picking up on it and suggesting it was true, especially there's a program on 60 Minutes in America which said that this was happening. And then, of course, it started happening around the world as well, different places, so that people were saying, the Russians are doing it everywhere. Now, the question is they couldn't actually prove it. They couldn't actually show any real evidence. They couldn't actually show a lot of evidence that people had these illnesses that were sort of from any unknown source. And the problem is, of course, headaches and things are rather hard to substantiate. Hearing loss is a personal thing. Brain damage is something a bit more serious, and you might be able to look into that. So there was a lot of confusion about what this supposed Havana syndrome was. But the final result is that people looking into it were saying it's not what it is claimed to be. It is not some extra group of Russians or whatever firing beams at you. People say it's a mixture of sort of group issues where everyone's getting sort of frightened together, mass hysteria, whether it's the other things where someone was suggested seriously that there's a compensation scheme for people suffering from this, so that might encourage people to get sick. And also they're suggesting that there's illnesses and conditions that things that people get anyway: headache, nausea, dizziness, fatigue, difficulty, concentration, disorientation, etc., etc. These are pretty normal things, and at some stage or another, probably everybody has it. As you get older, you probably have it even more. But one of the issues here was that there's a presumption, and there has been since the Cold War, that Russia especially is doing all sorts of things to upset America in the psychic race. And with the 70s and things, it was supposedly that they had psychics who could create havoc elsewhere, who could sort of fly missiles, who could just basically upset the American defense system. That became a problem, so the CIA were picking up doing their own research, etc. And they've gone through various stages of technologies which have been debunked as you go on, but nonetheless, this paranoia is still there. So therefore, when the Havana syndrome came on, there was a ready audience to believe in it. We've got an article in our magazine, in the next issue of our magazine, and this issue was dragged on too long, it says. It's basically wasting valuable time and resources, and all because politics has become intertwined with science. And it's this paranoia about Russian or the enemy, whatever, with a bit of a technology coating on it, which Americans have, in certain institutions, have always believed, unjustifiably, that Havana syndrome is just the latest in that. There will probably be more things coming up in the future. Does the technology exist to actually do this? According to some people, yes, it does. Suggestions of China-India warfare. China's the new Russia as far as this technology interference. The technology war continues in various forms, and this is just one element of it, and there doesn't seem to be any substantiation for this particular syndrome.
That's Tim Mendham from Australian Skeptics. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel. And on Facebook, just go to facebook.com/spacetime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.